The lecture today we are going to discuss about malware, and if the time permits, we will also discuss about some basics of intrusion detection system. Okay, so before we jump into the topic, any quick question about anything related to the course? So in the previous week, I graded your midterm project report. So I want to discuss some of the things that that have been. I mean, you should not do that, but many of you have done that, and I would like to clarify all those things in a session. So we will. So in today's lab session in the evening, the discussion will be around assignment 3. So Mehreen will be taking that lab session, and then hopefully in the next lab session, probably we can have that discussion about what I expect in a project report in the different sections of the project report. And then for the minor exam grading, so I'm almost done. So I know that some of you want to make a decision about auditing the course or withdrawing from the course based on the minor marks. So there is, so I am trying to release the marks by today. So hopefully that will be done. But yeah, I was really yeah, not happy with the way the answers were written in majority of the answer sheets. So majority means more than 50%. So I'm not talking about that everybody wrote unsatisfactory answers. So it's just that more than 50% of you did not write satisfactory answers, and that is a little alarming from for me. And therefore, what I thought was, because of this option of looking at the internet and then searching for answers, probably people did not read the basics, and therefore I have decided that in the major exam we will not have so we will not allow access to any electronic device, which means no access to the internet. So you will need to hopefully, so of course I cannot prevent access to books or notes, otherwise it will be very difficult. Um, so you can access to books, you can have access to books, or I mean any written or published work. But yeah, I hope that I will see better answers in the major exam. So any comment related to any of the things that I just said? No comments? Okay. Yeah, so I also need to probably put the midterm feedback on Moodle. I will also try to do that sometime today after I have released the minor grades. So please fill that midterm feedback as well. So hopefully you don't want to speak up, but probably you will be able to give some feedback on Moodle. Okay, so let's now move into this topic of malware. So I guess the way I'm going to discuss this malware is uh, just some giving you some theoretical understanding of malware, but I am planning to actually design the 4th assignment on malwares, so an intrusion detection system. So hopefully you will have the opportunity to have some hands-on experience with some malware soon. Probably not through the lectures, but by doing the assignment. Okay. Okay. So basically, a malware is a way of saying that this is a malicious software, and this malicious software targets your data. It could be the victim's data, it could be application, or it could be the system as a whole, whether it is the software part, operating system, or some hardware aspects as well. And then we could also think of it on a much larger scale, attacking the whole network. So these malicious softwares, what they do is they run some destructive or at least intrusive instructions. So either they try to compromise some of the security properties, for instance, confidentiality, integrity, that is very clear. And when we think about different types of attacks, some of which we also discussed in just last lecture about denial of service attack, then you could think of the malware is also trying to compromise the third important security property of availability. So this CIA triad. Now it is not only the availability of some network component, some website, but it could be the availability of the data that the user has on its system. So you must have heard about ransomware, when the adversary actually encrypts the data that is stored on your device and then asks money, ransom, for you to decrypt that data. And so that can also, that is also something related to availability of the data. So in one way or the other, malware is trying to compromise the basic security properties that we refer to as CIA triad. Okay, and then the malwares could be a variety of malware could do these things in a variety of ways. There are different ways of classifying malwares as well, but one important property that many of the malwares have is that they are persistent. Okay, so these are the modern malwares, and they pose what is called advanced persistent threat, APT. Even if you restart your computer, even if you just do a simple reboot, these malwares cannot be removed. So that is what typically could be easily understood by saying that this is an advanced persistent threat type of attack, that it is not very easy to get rid of. Some other way of seeing the advanced persistent threat is also that it is difficult to detect. So that is also, that can be considered as advanced persistent threat. So basically what we are trying to do is, we are trying to say that there used to be some conventional malwares 20 years ago. So there was some pattern to these malwares. But we are looking, when we are talking about modern malwares, we classify them as advanced persistent threats because they are much more advanced than the previous versions of malware. And these new versions, they cannot be detected easily. They cannot be, you cannot get away from these malwares very easily. And so therefore, we call them as advanced persistent threat. Okay, so any quick question about what is the goal of a malware? Okay. Okay, so then there are some popular type of malwares. Yeah, I should have included the ransomware here as well, but yeah, so these are some very popular types of malware. Okay, so the first one is something that we typically call a virus. So you will see that many times people use these terms interchangeably. And when you are a security expert, then you are expected to use these terms very properly. So when you talk about a malware, then it could be anything, any malicious software program. Okay, so then you can call it a malware. But then if you take one of the names that are being listed here, then you refer to a particular type of malware. And then based on that type, you know what properties are expected from that malware. Okay, so if we talk about a virus, okay, so this malware, which is called virus, so it may have many different properties. The basic distinguishing property for this malware is that it targets some benign executable code, okay, and it replicates itself into it. Okay, so you have some malware which actually targets a benign executable code, and it affects that benign executable code, and then it also uh, again targets another executable code and then copies itself again on that another executable code. So it is just targeting these different executable codes running on a particular system. Okay, so you think about a system, and then this virus came into your system, it compromised one executable code, and then it could go on to copying or replicating itself into another executable codes of your system. Okay, so then this type of malware will be called a virus. Now let's talk about this worm. Okay, so the second type of malware. Now, when we talk about a worm, then we are thinking about a network. Okay, so you are not just thinking about one platform, one hardware device, or one system. So we are now thinking about a network. So there on the network there could be a variety of hosts connected to the network, and then this worm could propagate through all these different hosts. Okay, so it some malware is in one of the hosts in one of the computers, and now that computer is connected to a network, let's say IIT Delhi's network, and then this worm or this malware now gets it starts affecting other computers connected to our IIT Delhi network. So this means that this type of malware is called a worm because it is now shifting or propagating through different hosts. Okay, so it is a network based propagation. Okay,
Sir,
so
how
now
does it is affect basically?
how does it affect?
Is there like a virus is replicating itself, or it is tampering with your executable files, right, sir? How does
Hmm.
worm is affecting? It is if it is only propagating, that it should not be an issue. But what is actually harming? I mean,
Yeah, so it is also doing the same thing. So that is what I showed you in the first slide, that there are some objectives of a malware. So it could be a variety of things. It could be compromising confidentiality, integrity, availability in many different forms. Just the victim's data, or some application, or the whole operating system. So that is the generic goal of a malware. Okay, so now when we talk about these different popular types of malware, each of these types could have one or more of those objectives. Okay, so this is the type based on the behavior of the malware. So this classification is based on the behavior. Now the final objective, which means that either compromising the victim's data or compromising the operating system, that is something that could be done by all of these different types. Okay, so this classification is based on the some properties but not on the objective. So this means that the virus could also compromise on the um, probably integrity of some of your data. A worm could also compromise the integrity of some data. So if a worm gets you get infected with a worm, it is possible that the worm can also um, or infiltrate some data from your device and then communicate it to some other attacker's device. So the property here is that so the property on which these classifications are being discussed is that what is the how your how the target or the victim is getting compromised, and what happens what is the behavior of the malware or the basic property of the malware. Okay, so that is the way we have shown these types to be, but their objectives could be very similar. Okay. Okay, so now let's look into the third type, which is the Trojan. Okay, so that is also something that is quite popularly used. So one of the critical way of identifying a Trojan would be that if you find a malware, okay, and it looks useful. Okay, so so something like you receive a file or let's say a bank statement, and it looks useful that okay, this is a bank statement, I should open this bank statement, but it also has some hidden malicious function. Okay, so that is why this name Trojan, and I hope some of you know the background of naming it, why we name it Trojan. So yes, so if so a worm or a virus does not have to be useful. Okay, so we don't expect them to be useful, but they are a type of malware which infect our systems. But in case of Trojan, that Trojan, so the malware will look useful, but then of course it has some malicious function that for which it has been designed. So that is, so those kind of malwares are called Trojans. Okay, and then we look into the type of malware, which is bots. Okay, so the bot is so with this name you could think of it as um, something which is being controlled remotely to target some other victims. So basically um, the compromised entity, the entity which has been compromised with this malware called bot. So you are not actually doing anything bad for that entity, but the attacker is actually exploiting that entity, that bot, to launch attacks or to do some malicious attack on some other victims. Okay, so that is the difference between bot and these other types of malwares. That the infected machine. So this bot or this malware has infected a machine, but probably it is not doing something um, malicious for this particular machine. But what it is doing is it is exploiting this machine to launch attacks on other machine, and that is why now we could classify this malware as a bot. Okay, and then let me just also bring one last type. So there are so based on, so if you look into the book, you will see a much longer list of types of malwares, and they are just defined based on what are some of the properties of those malware. But I have just taken these five popular types out of them. So and the last one is the spyware. So what this spyware is doing, it is collecting information from a computer and then transmitting it to another system. Okay, so that is uh, something this a spy. So it is working like a spy, so collecting information and transmitting it to attacker's system. So this spyware is again you could think of um, a virus getting you exploited as a spyware. So that is also something that is possible. A worm. So after this worm compromises a host, that worm can actually lead to a spyware. So these all these interconnections between these different types of malwares are always possible. But the reason why we have put in this terminology is to differentiate between these different types of malware, and when we are speaking about a particular type of malware, people understand what it is about. Okay. Yeah, so this is a very high level classification of these different types of malware. So any quick question about these properties? So I will go in a little bit of more depth for some of these, for instance, viruses or worms, but not much. But yeah, any quick question about at least the definition of these different types?
Sir, in the case of virus, it replicates in one single type of executable code, or it replicates to some different types like Word, Excel, PowerPoint, all other different types of software it
It
holds
can,
and replicates.
yes, it can replicate to all those different types of applications.
Okay. And by replication means the execution is like in a for loop or something.
Uh, so it is not actually a for loop. So it depends on the virus. Okay, so I have some demonstration which actually has a for loop, but um, so let me quickly show you the illustration first, and probably or let me just, okay, so I guess that is a good question, Ramita. So I will talk about whatever you have asked in a minute. Let me, because I'm going to talk about these things in any case. So let me take some other questions from other students as well.
Okay, sir.
Sir, I have a small doubt.
Mhm.
So, sir, it is like it is related to the Trojan horse. So,
Mhm.
what we do, like recently in the minor exam, we must have downloaded a lot of video, recording applications in our laptop and all. So, sir, if it seems that some of them might be Trojan horse, so they might be sending some to some connecting internet or something else. So, sir, isn't the responsibility of the operating system provider to check whether an application which is meant only to access the camera should not connect to internet? I mean, doesn't it relies on the OS developer and provider for that?
No, no, no. So I guess the responsibility of OS developer is to make sure that it gives you what you could think of as a base platform on which applications could be built. Okay, so if Microsoft starts to build all applications, then you will see applications like Microsoft Teams, which are very difficult to use to chat, and then it is not possible for just uh, one uh, company to build all possible applications. Okay, so the operating system developers, they give you a platform, a base platform on which different applications could be built by different people or different industries. So then if you give them this base platform, then you at the start you cannot limit what should be used by what and what should not be used by what. Okay, so now it is about, now let's so how to prevent these kind of activities. Okay, so then you have these intrusion detection systems, antivirus or these kind of anti-malware systems that are developed separately. So the operating system developer also provides you some of these facilities, and then there are McAfee, and there are other Quick Heal, and then there are other antivirus softwares. So they try to detect whether the a particular software that you have installed is actually doing what it is expected to do or not. So as you said that if it is just need to record the screen, then it should not get connected to the internet. Okay, so if that is something that you define as a policy for classifying a malicious and a benign application, then yeah, that is a justifiable policy, and whatever tools that you are using, McAfee or Quickfill, it should detect that this is doing something malicious. It did not ask for that permission, and but it is just doing that. So it is did not ask for connecting to the internet, but it is getting connected to the internet. So that is the part of intrusion detection system. And I would say that when you accept all, when you click that button of accept all, many times you don't read what you are actually giving permission for. So when you are installing that software, you are already giving it the permission to connect to the internet. And then you go ahead and expect that your operating system will detect it as an anomalous behavior, then that is definitely a wrong expectation. So if you have given, so there are two ways to do it. So either all permissions are requested from you one by one, and that is one way, or or when you accept all permissions go together. So that is something very difficult to manage in a complex user systems like a computer these days. So yeah, so definitely that base platform also plays a role. So therefore you have Windows, which is very prone to malwares, and you have Linux based systems which are more robust to these kind of malwares, because there are some uh, set of repositories through which on from where you actually download stuff. So yes, so yeah, so this is a complex environment in which these softwares are being developed, and yeah, so that is a very good question, but yeah, I don't think it is the sole responsibility of the operating system provider to prevent Trojans.
Sir, is Microsoft Security Essentials enough for Windows system, or we need to have more like McAfee and all?
So we will talk about intrusion detection system, and hopefully you will get some intuition about what is enough. So basically, um, the everyone is trying to detect malware which is coming to your system. So Microsoft Security Essentials is trying to do that. McAfee is trying to do that. So one of them could do better than the other. So that is always possible, and therefore we have so many these antivirus applications that are in the market, and people are using all the different antivirus tools. So some antiviruses are being detected by one, some are not being detected by the other, and therefore one of them is popular. Or there could be other things that some of them are more lightweight in terms of computational resources that they take from the computer or the platform on which they are running. So these kind of considerations lead you to choose one over the other. But when we will discuss intrusion detection systems, you will see that there is always a chance that some virus or some malware may not be detected by your tool, whatever tool you are using. And yeah, so I do not know if Microsoft Security Essentials is better or McAfee is whatever is better. But what I would say is that none of them are foolproof, which means none of them could provide you 100% security guarantee. So that is the basic argument that we could make. So probably just having both of them is better than having just one of them.
Sir, it
Okay.
is also possible that these antivirus can also contain viruses and trojans. So, is there any way to detect those things as well?
um, that is definitely something that has been contemplated in social media, that yeah, these um, tools which we install to protect ourselves, they may self contain these viruses. So see, it is always possible that this is the case, but yeah, I guess you have to trust some system in order to actually work on or get connected to the internet. You need to have some security, and then you trust McAfee to provide such security, or Norton to provide such security. But So the basic argument is that if that software that you have installed to detect any malware on your computer, if it is doing something malicious, or if it is actually acting in a way which is not expected it to work, then definitely it could be considered to contain some malware. Now, how will you detect that malware? That is difficult to say. Probably if you have two different antiviruses, and people do not say that, at least these tools, they always mention that you should not have two different antivirus tools on the same system, because yeah, so that is something you should not try. But if those two tools are working on a system together, then definitely it is possible that if one of them is behaving in a malicious manner, then the other one will detect that malicious activity. But yeah, having two different such tools may itself create problems. Like, one of them will always detect even the benign activity of the other one as a malicious activity, because it would be scanning many of the executable codes in your system. One of the tools might be scanning them, and then this could itself be considered as a malicious activity by the other tool. So therefore, installing two tools on the same computer is definitely something which is not encouraged. But yeah, if it is possible, then yeah, you can have two tools installed, and then one of them could detect the malicious activity of the other. Okay. 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 So now, although I will talk about these different phases of the malicious activity for virus, but you could easily extend these different phases for other malware types as well. So worms and others as well. Okay. So for specifically for virus, we could think of the infection progress in 4 steps. Okay, so these are very intuitive steps. So the first step could be a dormant. So the virus could be in a dormant state, and it is not doing anything. So it is just lying there. Okay, so that could be a dormant stage. Or for instance, we can also, if we are thinking about another malware type, let's say Trojan. So Trojan is just probably has been already developed by an attacker or a hacker, and it is lying there somewhere. And then the second step is the propagation. Okay, so this is where the infection to the host actually happens. Okay, so, or the platform or the system actually happens. So this step is where um, which is probably the most important step, and that is where you could actually have these different tools which could try to prevent such infections. Okay, so this is the propagation, means that now your system has got infected with that virus. Or if it is Trojan, so now you downloaded that Trojan or some application with the Trojan, and now your system already has that Trojan ready to actually do some malicious activity. And then the third phase is the triggering of the malware. Okay, so although your system has already been infected, but it is possible that this virus will not trigger until, let's say, if it is my computer, until I open Microsoft Excel. So if I open Microsoft Excel, only this virus will get triggered. Okay, so, or there could be some other type of triggering mechanism. For instance, the virus will trigger at midnight on March 5th. So something like that. So there would be some triggering criteria for the virus or malware. Okay, and then finally is the execution. So what is whatever goal has been decided for that virus or for that malware, now that virus will try to achieve that goal, and that is the execution phase. So this is a very intuitive set of four phases, and typically these malwares are studied in these four phases. So what are some of the things that could be done in each of the phase to detect or to prevent these phases? So for instance, so of course dormant is just a phase which is uh, the starting state, so we are not worried about too much about it. So propagation is the phase where we want to prevent infection of our devices. So there could be some preventive mechanisms. And then triggering, so there could be some ways that you could develop that even if your system is infected with a virus, so the virus could not be triggered easily. So the virus, so whatever triggering criteria the virus has come up with, it is possible to actually prevent virus from accessing to that triggering criteria. So for instance, access, so the I gave you an example of triggering the virus at midnight on March 5th. So if some way you prevent access of whatever executable that virus has to a clock from where it could get the time, then you could make sure that this virus does not get triggered. So there could be different ways of preventing the triggering of virus as well. Okay, so first, when it was propagating, you could figure out ways to stop propagation. Um, then you could have ways to prevent triggering. And then once the virus has executed, then since the damage has already been done, so now at this point you need to develop ways to detect it. So you could also um, uh, try to prevent the amount of damage that you might have because of the virus. But yeah, now that virus is actively taking some steps, it is actually executing some functions. So there is a way to, there could be a way to actually detect whether this is a virus or not. Okay, so so these different phases actually help you to um, come up with ways to prevent or detect these viruses, and therefore we study these viruses in different phases. Any question related to these phases? Okay. Okay, so now let's look into an illustrative example of a virus. Okay, so this is so I think we should start from the uh, main part of this program. So if you see in this main action block, so the first is, so these are very intuitive names that are given here. So the first probably instruction, let's just call them instruction, is to attach to program. Then the second is that if the trigger condition is satisfied, then you execute something, execute payload, and then you again go to main. Okay, and this is what is happening. Okay, so now attached to program is a procedure that is being defined here. Execute payload is a procedure which is defined here, and trigger condition is defined here. So what this attached to program does is that it will repeat some of these things, which will allow it to infect different programs and see if it has already infected a program. Then it will, of course it has already infected, so it does not need to do anything, and then it will go ahead and infect another program. And what does this infection means? So it is going to probably add some of these functions as part of that executable program. Okay, so there is already some program which is running, and this code will become part of that program. Okay, so what will this attach to program do? So it will go to a program. So in this case, get random program, but you can also specifically target a certain program, and then see whether this program has already been infected or not. So if it would have been already infected, then this is something, this program V123456 is something that you will see at the start of the program. So if the first program line is not equal to this, then of course you go ahead and prepend this program V that we have here to that particular file. Okay, so you first get access to a new program, and then you try to check whether this program has been infected or not. If it has been infected, great. If it has not been infected, then you go ahead and infect it. Okay, and you prepend this whole program uh, to that victim program. Okay, so that is what is being done in the attached to program. Then we should look into the trigger condition. Okay, so you could define any trigger condition. As I said, it could be based on time, it could be based on a certain program or anything. And then it will have some execution program as well, which means that if the virus code is triggered, then you go ahead and do something. So this execute payload is you execute some instructions. So for instance, if it is now if this virus is going to be utilized for spying activity, then you go ahead and read some information, some data, and then send that data over the internet. So this is a very nice way of demonstrating those different phases of virus as well. And now I hope this question about this for loop is also very clear, that every unit of this virus or every program infected with a virus can infect other programs. Okay, so every program that is infected with a virus can infect other programs. So now that, so if you see that initially you might have, it is like the propagation of this COVID-19. Okay, so every infected person could infect other persons, and then you will see an exponential growth. So that is also true in this case, that these viruses, they definitely work in the way that one infected program can infect others. So it is in some sense running in that running in some loop, which can actually lead to infection to the all programs that are running on the computer, or probably some set of programs running on the computer. Okay, so but it is not directly a for loop.
Sir, can you please explain this number 1 2 3 4 5 6 7 once more? Like, what is
So it
it
is
used
just a
for?
random ID.
Okay.
So it is just a random ID that is prepended at the top of this virus, the program corresponding to the virus. Okay, so when the virus has to check whether a target program has already been infected or not, then it will go ahead and look at for the first line of that program, and if it sees that, okay, I have already infected this program, then I don't need to do anything. Let's just move to another program and see if it is infected or not. But if it finds that the first line of the program is not does not contain this random sequence, whatever the random sequence here is, then it means that this program has not been infected. So then what it will do, it will go ahead and prepend this whole thing in that program. So now your program will start with this random sequence. So the next time the virus will try to see this program, it will figure out that this program is already infected.
Okay, sir. Got it.
Okay, any other question? Okay. Okay, so let's now talk a little bit about worms. So very intuitive and generic things. So as I said, the same different phases could be applied to worms as well. The different phases that we talked about in terms of virus. And some of the things you already know how we get these malware. So we can get this malware through email. So that is one way of propagating the malware. And in this case, since we are thinking about how to infect other hosts, so if there is an infected host, then how it will infect other hosts. So it could send that malware over email. That is possible. Uh, you could download a file containing a malware, and now your system will get infected. Or there is also a possibility of some remote execution that can happen, which can infect you for to this malware. Okay, and then what could be some of the things that could be done by worm? Okay, so worm can actually so do many things, but just for illustration, we could say that what it could do is it could search for all the contacts that your system has, and then it can share that information with an adversary. It can also try to figure out if there are some other vulnerabilities in your system. Okay, so initially, so your system could be attacked in multiple layers, which means that first you get a worm which actually analyzes your system for security vulnerabilities. So for instance, initially it will not know, so initially any adversary will not know that that probably you are not using McAfee antivirus, or you are not using Microsoft Essentials. So initially they will not know, but once a malware comes to your system, they will scan that malware will, or the worm will scan your system, figure out that you are not using Microsoft Essentials, or figure out you are not using McAfee. Now then some malware will be sent or will be directed to your system, which may have been detected by these security tools or detection tools, but because you have not installed them, they will not be detected by your system. So that kind of scanning is something that could be done by worm as well. So, and you could see these attacks in hierarchical manner, that one attack leads to or opens the window for another attack. Okay, so this is uh, okay, so let me just quickly talk about this figure, and then probably yeah. So whether it is a virus that we are encountering these days, or whether it is a worm. Okay, so in this logic applies to many of these malwares or real world viruses as well. That if you have time on the x-axis, and you have either number of hosts, or number of programs running in a host, or number of people in a country or in the world. So if we have that on the y-axis, which can range from 0 to 1. Okay, so this is you can think of it as fraction of hosts. So specifically, when we are talking about worm, we will talk about hosts. So let's say there is a network which has 100 hosts. So then this fraction 0 to 1 is actually representative of how many hosts out of those 100 have been infected by the worm. So if you see the fraction of hosts infected, so if you see this curve, you see an an exponential growth initially. So every infected host can infect other hosts. So if now you start from one host, so now you have two. So if it infects one other host, so now you have two hosts, and now both the hosts can infect one each. So now you will have four hosts. Now all four of them can infect one each, and then you can have 8 hosts infected. So initially you will see an exponential rise in the number of infections. But as the number of hosts start decreasing, so now you have only 100 hosts in the network. So at some point, you might have already infected 90 hosts. So now, although you have 90 hosts which could infect other, if they each of them infect one host, they could infect 90 other hosts, but there are only 10 hosts left for infection. And therefore, you will see those 90 hosts infecting only 10 hosts. So if you plot all this logic that I'm saying, so you will see that if your fraction that you are representing from between 0 to 1, and on the x-axis you have this time, you will see that initially it will have an exponential rise, and then this will flatten over time. So when you are reaching the level where almost all of your hosts are already infected, then you will see the flattening of this curve. Okay, and this is just the other curve is just um, 1 minus the fraction of hosts infected. So it will of course show a reverse trend. Okay, and a few more things that are shown on this figure is that you may have a slow start phase. So for instance, one infected host will infect the other. So initially in 1 unit of time, you may have only 2 infected hosts. In the third unit, you may have 4 infected hosts. In the fourth unit, you will have 8 infected hosts. So although in the first unit of time, you had only one additional host that was infected. In the second unit of time, you had 2 additional hosts that were infected. In the third unit of time, you had 4 additional hosts that were infected. So although you may have slow start of the worm propagation, you will see a very fast spread of this propagation. And then again, because the almost all the hosts have been already infected, you will have slow finish. So this is also something which is interesting to note about these worm propagations. Okay. Yeah. So any quick question about um, this brief information about worms and how they actually propagate? Okay. So yeah, so I also want to just highlight a few things about Trojan and bot, and probably I will take up the intrusion detection system in the next class, which is tomorrow. So I have already said this basic thing about Trojan, that it looks benign, so benign looking, but it is malicious malware. So then these Trojans could also be divided into different subtypes. Okay, so once the Trojan comes to your system, then how this Trojan behaves. Okay, so a malware which looks benign but has this possibility of doing this malicious activity, that is called Trojan. So one category of malware is called Trojan, and then the Trojan can further be divided into these different categories. So in one category, so the Trojan will have some benign function because it looked like doing something, so it must have some benign function. So it will continue. So when it is infects your system, it will continue to perform that original function, but then it will also do this additional malicious activity. Okay, the second type could be that it will continue to do the original function, but then modify those original function in such a way that it will actually lead to a malicious activity. Okay, so for instance, sending some information to a remote entity. Okay, so that information should be encrypted, authenticated, and then sent to some remote entity. Okay, so that is the purpose of, let's say, a program, and you'd install that program, and it encrypted, authenticated that information, but it's sent to a different entity, the attacker in this case. So although the program is supposed to do encryption, authentication, and send it to a remote entity, but it has modified the receiver, and therefore this could be considered another type of Trojan. And then there could be a complete replacement of the original function as well. So it was there to actually do the screen recording, but now it is collecting information from your computer and then sending it to an attacker. So that is also something that could lead to a different types of Trojans. And when we are, so the reason why we divide these things into different types is to develop mechanisms to prevent these different types of Trojans or malware. Okay, any question about these different possibilities in which the Trojan can behave? Okay. Okay, and then we have also talked about the DDoS attack in the previous lecture, and I said that these IoT devices were compromised and they were utilized as bots to launch the attacks on the servers of DING, which is and therefore the attack that this DDoS attack that happened a few years ago, that was called a DIN attack, and it was a DDoS. So there again, I meant that when I said that these IoT devices were compromised, the IP cameras were compromised and utilized as bots. This meant that these devices were infected, and then they were utilized to attack other machines. Okay, then you could utilize them to do DDoS. We already saw an example of that. It could be just utilized to do spamming. So just spamming is also something which is an undesirable activity, and therefore the bots could be utilized to do that. Then these bots could also be utilized to do key logging, or it could actually be again a precursor to install these malicious add-ons. So your system is now um, allowing these malicious add-ons to get connected, because now you have this bot. Now your system is being uh, exploited by the attacker as a bot. So now it is controlling your system to do all these different malicious activities. Okay, yeah, so I will talk about some countermeasures, and then I will go into depth for intrusion detection system later. Any last question about this discussion about malware? So this is a very theoretical discussion. As I said initially, that I am planning an assignment for malware. So hopefully you will get more hands-on experience of looking into a malware and what malware can do. But yeah, at least having some basic understanding of the classification and activities that these malwares could do is also very helpful. Any last questions? So we will start with the countermeasures in the next class. Okay, so let me, yeah, we will talk about it tomorrow. Okay, so we'll see you tomorrow then. Bye bye.